What if I told you the future already exists, not as a prediction, not as destiny, but as something physically real, sitting right next to the past and the present? And the only reason you feel time moving is because your brain can't see the whole picture. Is time real, or is it just a stubborn illusion? You look at your watch, you plan your day, you remember the past and anticipate the future. It feels incredibly real, right? But what if I told you that for many physicists, the concept of time as a flowing river from past to future is at best a useful fiction and at worst fundamentally wrong? Let's dive into what physics really says about the nature of time. To start, let's think about how we usually experience time. It seems to have a clear direction, an arrow pointing from yesterday to tomorrow. This is what we call the arrow of time. We remember the past, but not the future. A broken egg doesn't spontaneously reassemble itself. This one-way street feels like a fundamental law of the universe. And for our everyday lives, it is. This arrow is beautifully explained by the second law of thermodynamics, which states that in an isolated system, entropy, or disorder, always increases. Think about your room. It's much easier for it to get messy than for it to spontaneously tidy itself up. The universe is the same. It started in a highly ordered, low entropy state at the Big Bang and has been getting more disordered ever since. The arrow of time, then, is simply the direction of increasing entropy. The past is the low entropy state, and the future is the high entropy state. That's why we remember the past. It left a more ordered, lower entropy record. So, problem solved? Time is just entropy? Not so fast. This is where things get really weird. If you look at the most fundamental laws of physics, like Einstein's theory of general relativity or the equations of quantum mechanics, they don't really care about the arrow of time. They work just as well forwards as they do backwards. In these equations, time is just another dimension, like length, width, and height. It's part of a four-dimensional fabric called spacetime. Let's unpack that. Imagine spacetime as a giant loaf of bread. Each slice is a moment in time, a snapshot of the entire universe. From the perspective of fundamental physics, all the slices, the past, the present, and the future, exist simultaneously. The entire loaf is just there. The Big Bang isn't a moment in the distant past, it's one end of the loaf. The ultimate heat death of the universe isn't a far-off future, it's the other end. All of it coexists. This is the block universe theory. In this view, your birth, you watching this video right now, and every moment of your future are all equally real, just located at different coordinates in spacetime. The feeling that time is flowing is an illusion, a trick our minds play on us to make sense of our journey through this block universe. So why do we experience this flow? Why does the present feel so special? This is one of the biggest mysteries in physics. One idea, championed by physicist Carlo Rovelli, is that time isn't fundamental at all. It's an emergent property, something that appears at a larger scale from the interactions of smaller, more fundamental components, much like how the wetness of water emerges from the interactions of individual H2O molecules, none of which are themselves wet. At the quantum level, the universe is just a fizzing, probabilistic dance of fields and particles. There is no master clock ticking away. Time, as we know it, only emerges when we, as macroscopic observers, interact with a small part of this vast quantum reality. Our limited perspective creates the illusion of a sequence of events, a flow of time. Now let's bring in Einstein's theory of relativity, which adds another layer of complexity. Einstein showed that time is not absolute, it's relative. How fast you experience time depends on your speed and the strength of the gravity around you. This is called time dilation. Astronauts on the International Space Station age slightly slower than we do on Earth because they are moving very fast and are in a slightly weaker gravitational field. GPS satellites have to constantly adjust their clocks to account for this effect, or their navigation data would be completely wrong. This means there is no universal now. My now could be your past or your future if you were moving at a different speed or in a different gravitational field far away. If we can't even agree on what now is, how can time be a fundamental flowing river? The idea of a single universal present moment simply dissolves. Let's go even deeper, to the very edge of physics, with something called the Wheeler-DeWitt equation. This is an attempt to combine quantum mechanics and general relativity into a theory of everything. When physicists tried to write this equation for the universe as a whole, something baffling happened. The variable for time, t, just dropped out. The equation describes a static, timeless universe. This doesn't mean nothing happens. It means that at the most fundamental level, the concept of change over time might not be the right way to describe reality. Instead of things evolving in time, the universe might just be a collection of all possible nows existing in a timeless configuration space. Our perception of a dynamic, evolving universe could be an illusion arising from our position within this static block of spacetime. So, what does this all mean for us? Should you throw away your calendar? Probably not. Even if time is an illusion at the fundamental level, it's a very persistent and useful one. It governs our biology, our psychology, and our society. The thermodynamic arrow of time is very real for us complex beings. We are born, we live, we create memories, and we move towards the future. The disagreement isn't about our experience, it's about whether that experience reflects the ultimate nature of reality. Is time a deep feature of the cosmos, or is it a feature of our relationship with the cosmos? The answer seems to be leaning towards the latter. Physics suggests that the universe itself might be timeless, and that the flowing river of time we perceive is a product of our own consciousness, our entropy, and our place within the vast, static block of spacetime. Thinking about time this way can be mind-bending, but it's also incredibly profound. It changes how we might view our past and future. If the future already exists, does that mean our lives are predetermined? Not necessarily. Quantum mechanics introduces a deep level of uncertainty and probability, so the future might exist as a spectrum of possibilities rather than a single fixed path. This perspective challenges us to see our lives not just as a fleeting sequence of moments, but as a complete, existing pattern within the four-dimensional tapestry of reality. Every moment, past and present, has its permanent place. The feeling of loss might be softened by the idea that the past isn't gone, it's just in a different location in spacetime. The debate is far from over. Physicists are still grappling with these ideas, trying to reconcile the timeless world of fundamental equations with the time-filled world of our experience. Maybe there's a missing piece of the puzzle, a new theory that will unify these two perspectives. But for now, the next time you glance at a clock, remember that you're not just measuring a simple ticking. You're participating in one of the deepest and most beautiful mysteries of the universe, the grand and perhaps stubborn illusion of time. Thanks for joining me on this journey through spacetime. If this bent your mind in the best way possible, be sure to like this video and subscribe for more deep dives into the cosmos.